right, here are the answers to the Topic 9 test. This test is actually, it says 27 out of 26 because I did not have you graph this one. I gave you this graph, and I will go through the point values as we go. So, problem number 1 was to find the solutions of that problem given the graph. The solutions that make this quadratic equation true are 0 and 2. So all you had to do was say x is equal to 0 and x is equal to 2. Problem number 2 is worth 3 points. If you use factoring, but you got it wrong, then that's -1. If you factored it completely incorrectly, then you got -2, and if you were just totally off, you got -3. So when you factor x squared minus 6x minus 7 equals 0, you should get x minus 7 times x plus 1 equals 0. And then using the zero product property, you would say that x is equal to 7 and x is equal to -1. Problem number 3 is finding the solutions by using square roots. If you forgot the plus or minus sign, I did take off a 1 point. If you don't take the square root, then I took off 2 points. And if you just solved it incorrectly, then I took off 3. So if you solve this one, it's actually already isolated the square root you want to undo first. So take the square root of both sides to get 2x minus 1 is equal to plus or minus 5. And then you want to add 1 to both sides. Now this is where it gets a little bit tricky in that we have a positive 5 and a negative 5 here. So you have to add that 1 to positive 5 and negative 5. So you get the answer 6 and -4. And then you divide both sides, or all 3 sides, by 2. And so you end up with x is equal to 3 and x is equal to -2. Problem number 4 is finding those solutions by completing the square. Remember, with completing the square, you want to make sure that you have that 8 on the other side. So first thing I did was subtract that, and then you want to use this b over 2 and square it in order to determine what that c value is that you add to both sides. So I did 12 divided by 2, and that gave me 6, and then 6 squared is 36. So when I factored the perfect square trinomial, I got x plus 6 quantity squared, and when I added -8 plus 36, I got 28. Then, to solve, you take the square root of both sides, and you get x plus 6 equals plus or minus the square root of 28. The square root of 28 simplifies to 2 times the square root of 7, and then I subtracted 6 from both sides, and I got an answer of x equals -6 plus or minus 2 times the square root of 7. I also gave you credit if you left your answer as -6 plus or minus the square root of 28. Problem number 5 was solving using the quadratic formula. Okay, so you do have to isolate this so that it is equal to 0. And so I got 2x squared plus 6x plus 3 equals 0. And then I plugged in my a, b, and c into the quadratic formula. So it ends up being -6 plus or minus the square root of 6 squared minus 4 times 2 times 3 all over 2 times 2. So -6 plus or minus the square root of 36 minus 24 is equal to 4. When I subtract 36 minus 24, I get 12. And so I end up with -6 plus or minus the square root of 12 all over 4. You can simplify the square root of 12 to 2 times the square root of 3, and you can actually simplify that further by dividing each of these things by 2. So it ends up being -3 plus or minus the square root of 3 all over 2. Now I accepted any of these 3 answers. Now problem number 6, I chose to use the quadratic formula because this was not something that was easily factorable to me, and in order to solve it quickly, I just knew that the quadratic formula would be my best choice. So I plugged in my a's, b's, and c's, and I got -4 plus or minus the square root of 4 squared minus 4 times 1 times -3 all over 2. I simplified under the radical and got 16 plus 12, which is the square root of 28. So negative 4 plus or minus the square root of 28 all over 2. That is an acceptable answer, but you can take it a little bit further and actually say that it's negative 4 plus or minus 2 square root of 7 all over 2. And then you can actually simplify that further by dividing everything by 2 to get negative 2 plus or minus root 7. Problem number 7, if you gave a really good explanation of why you chose the method that you did, I gave you 1 point extra credit. Number 8 is finding the discriminant. In order to find the discriminant, you need to do b squared minus 4ac. In this case, the b is negative 3, so negative 3 squared is 9, and then 4 times 2 times 1 is 8, so you subtract 8 to get 1. Number 9 is saying, based on your solution to number 8, how many solutions does this have? It's positive. So because it's a positive, that means it has 2 solutions, and you needed to explain that you knew that because the number was positive. Problem number 10, now we're talking about nonlinear systems. Problem number 10 is no solution because the line and the parabola do not cross. Problem number 11, you needed to solve using substitution. So I substituted the 5x into that quadratic. And when I did that, I then combined like terms by subtracting the 5x to the other side and got 0 equals x squared minus 9. I chose to solve this using square roots because I could add the 9 and then take the square root of both sides to get x equals plus or minus 3. Now, I had to plug in both positive and negative 3 because in this case, this quadratic and this line cross each other in 2 places. So I plugged in positive 3 to get out positive 15, and I plugged in negative 3 to get out negative 15. So my 2 ordered pairs are 3, 15, and negative 3, negative 15. And then number 12, we had to solve using elimination. So I actually multiplied the first equation by negative 1 to get negative y equals negative x, and then eliminated the y's. So I got 0 equals x squared minus x minus 3x, which those combine to get negative 4x. And then I chose to use factoring to solve this one. So I pulled out an x, and so it's x times x minus 4, which means that my x equals 0 and 4. Well, when I plug that back into my equation, that means my y values are the same. So my 2 ordered pairs are 0, 0, and 4, 4.